Section 2.5, Equivalent Statements and De Morgan's Laws, Video 2. In this video, we will cover the following objective. Determine if statements are logically equivalent. Example 3. Use truth tables to determine if any of the following statements are equivalent. Statement 1, I meet the job requirements if I have at least 2 years of experience and completed a certificate program. Statement 2, I have at least 2 years of experience and meet the job requirements if and only if I completed a certificate program. Statement 3, if I don't meet the job requirements, then I haven't completed a certificate program or I don't have at least 2 years of experience. Notice that the first statement, we can rewrite it as an if-then statement. The if part appears in the middle of the statement, and it might be better to rewrite this in a different way, in an equivalent way. So I'm going to write it as an if-then. So if I have at least 2 years of experience and completed a certificate program, then I meet the job requirements. So this is statement 1, written in an equivalent way. I'm going to use letters to represent simple statements that are part of these statements. So I'm going to let P stand for I have at least 2 years of experience, because that's one simple idea or simple statement that is involved. So P stands for I have at least 2 years of experience. I'm going to let Q stand for I completed a certificate program. And I will let R stand for I meet the job requirements. Now notice that I use statement 1 to come up with these, but notice that these simple statements are also involved in statement 2 and in statement 3, and that there are no other simple statements involved. So we're only talking about having at least 2 years of experience, meeting job requirements, and completing a certificate program. All right, so now that I have, and again, this was mentioned in a different video, but we could use different letters. It doesn't have to be P, Q, and R. And also, it doesn't matter which letter represents which statement. So we could set this up however we want, but then we just have to be consistent when we carry it through. So this is how I've opted to set this up. But again, there's more than one right way to do this. So now what we're going to do is we're going to write the statements in symbolic form. So statement 1, notice it's an if-then statement. So if I have at least 2 years of experience, which is P, then, and, so if I have at least 2 years of experience and completed a certificate program, which is Q, then I meet the job requirements, which is R. So that's how statement 1 can be written in symbolic form. Statement 2 up above here, I have at least 2 years of experience and meet the job requirements. So I have at least 2 years of experience and meet the job requirements if and only if, so this comma here shows me that those are grouped together, if and only if I completed a certificate program, which is Q. Lastly, statement 3 in symbolic form would look like this. Notice that this is an if-then. So if I don't meet the job requirements, so that would be if the negation of are, then this comma here shows me that the rest of this is going to be grouped together. Then I haven't completed a certificate program, which would be the negation of Q, or I don't have at least 2 years of experience, which would be the negation of P. That's what statement 3 would look like in symbolic form. Now, to determine if any of these statements are logically equivalent, I could create truth tables and then compare the truth values for these overall statements. I can make 3 different truth tables and then compare, or I can set this up in one big truth table, which is what I'm going to do. So we have to start with P, Q, and R. In statement 3, all of these are being negated. So we're going to make columns for those. We're going to set these up the same way we've always done in previous videos. We want to ensure that we hit every possible combination of true and false for the simple statements. Negating means that we're taking the opposite truth values. Those just looked a little messy, so I just rewrote them. Okay, so now for statement 1, I'm going to look at the parentheses first. So we have P and Q. So up here in statement 1, I want to look at the parentheses first. So we're putting an and between the P and the Q columns, which would be true only when both parts are true. Otherwise, it is false. And then now I'm ready to make a column for statement 1. Due to the fact that we don't have a lot of space, I'm just going to write statement 1 there. But recall statement 1 is if P and Q, then R. So it's an if-then. So we have if P and Q, then R. We're looking for the antecedent to be true and the consequent to be false, because that's when this if-then statement or conditional statement will be false overall. That is the only case where that happens, so the rest of these will be true. So those are the final truth values for statement 1. All right, now let's move on to statement 2. I'm going to start with the parentheses, P and R. So we're putting an and between these, which will be true when both parts are true, which happens in the first and the third row. Otherwise, it will be false. Okay, and then I'll be ready to make a column for the entire statement 2. So recall that statement 2 is if or P and R, if and only if Q. So we're creating a biconditional statement between the Q column and the column that we just created. If and only if statements are true when both statements have the same truth value. So that happens in the first row. That happens in the 4th row. And then that happens in the 7th and 8th rows. That's where the truth values match. The rest of these will end up being false. Okay, lastly, we can move on to statement 3. So in statement 3, we're going to work with the parentheses first. This would be the negation of Q or the negation of P. So we're putting an or between these. Recall, or statements are only false when both parts are false, which occur in the first 2 cases, and then otherwise this will be true. And then lastly, we can make a column for the entire statement 3, which recall is if the negation of R, then the negation of Q or the negation of P. So we're creating a conditional statement, an if-then statement. The negation of R is the antecedent, and negation of Q or negation of P is the consequent. We're looking for the antecedent to be true and the consequent to be false, because then it will turn out false in that case. That's the only time where this happens. So this is true everywhere else. All right, so now in order to determine if any of these statements are logically equivalent, what we would need to do is we would need to compare the truth values, the final truth values for each statement. So we're going to look at the columns that represent overall statement 1, statement 2, and statement 3. Notice that the truth values in statements 1 and 3 match. They're exactly the same for all 8 cases, or for all 8 rows. Notice that the truth values for statement 2 are different. So I know that statements 1 and 3 are logically equivalent. This concludes example 3.